Hey guys, I'm Chiku from Chiku Study Corner, and today I'll be dealing with the chapter 1 of Physics class 12, that is electric charges and fields. So without any further ado, let's get into the chapter. So first we'll discuss what is electrostatics. It is a branch of chemistry which deals, it's a branch of physics which deals with static or stationary charges. Charges, fields, and electric potential. Okay? So, now to talk about charges, we know what is charges, no? There are two types of charges that is defined by Benjamin Franklin. So, we will see about charges. Charges are intrinsic property of current. So, charges are of two types. Yeah? First one is positive charge. The second one is negative charge. Okay? Now there are some properties of charges. We'll discuss about each property in detail. So, first property we have to learn over here is properties. So, the first property that we have to learn is what? Like charges repel. Unlike charges attract. That is the first point. Second point is additivity nature. Additivity. What is it? It's simply that charges, if there are a lot of charges, they will just add up like real numbers. So if there is Q1, Q2, Q3 and Qn, then Q total would be equal to Q1 plus Q2 plus Q3 plus Qn. So this is the second one. The third one is quantization of charges. So we'll write it. Quantization. So over here it says Q, that is charge, is equal to N into E. E is the charge of electron. Charge of a single electron. Okay, a electron, and N is the number of electrons. Okay, so this is what is quantization. The next point that we have to discuss is about conservation of charges. So conservation. So it says that what an isolated system would have its charge as a constant. That is, Q is equal to a constant for an isolated system. So the next thing that we have to discuss, we finished about properties. Now we have to discuss about the methods of charging. So we have to learn three methods of charging. So let's list the three methods and then we'll learn about each in detail. So methods of charging. So the first method is friction. Second one is conduction. Third one is induction. So what all are they? First one is charging by friction. Second one is charging by conduction. The third one is charging by induction. So first we discuss about charging by friction. Charging by friction is also, it's a very common one. We all know about the example of friction. Charging by friction. We all have taken scale and then rubbed it in our hair and then taken up bits of papers and that scale attracts. That's just the same as frictional energy or frictional charging. So first point is charging caused by rubbing. Charging caused by rubbing. So what is the example of this? Examples are silk and glass rod. When you rub a silk cloth or a glass rod and then keep it, the silk cloth will attract to the glass rod. So that is charging by friction. So charging by friction is also known as frictional electricity. The charge produced is known as frictional electricity. So the next one we have to discuss is conduction. So let us see what is conduction. Now we have to assume something for conduction. There is a case if two charged bodies are of same size and same shape, then if there is 2Q, okay, if there is 2Q in this and if there is 4Q in this, when they are coming to contact, okay, they have come to contact 2Q and 4Q. So when they come to contact, what would happen? There would be equal sharing of the charges. So what would be the result of this? How do you find what is the charge in both of them? You add 2 plus 4 divided by 2, that is 6 divided by 2, that is 3. So what will happen to this? This would become 3Q and 3Q. See, this is the charging by conduction. Over here there is direct contact happens here. See this direct contact. So this is all about conduction, charging by conduction. The next point is charging by induction. So let's see. This is charging by induction. So for charging by induction, let's take a charged body. Let's take this to be this is an uncharged body, and then a charged body is taken. A charged body can be a charged rod or a charged sphere, anything, and you keep it close to this uncharged body. Okay, this is a neutral body. Okay? There's no charge quantization, or there's no charge prominent. There's no positive charge, no negative charge. It's a neutral body. So first let's take negative charges. So we'll bring I took a rod, and this is negative charges in the rod. So I kept it close to this, sphere. The sphere is neutral body. So what happens when like charges come, they repel. When unlike charges come, they attract. So the negative charge in the neutral body would move to the opposite side. Okay? And positive charge will get accumulated here. And then what happens? We are giving it to it's earth. It's now given an earthing wire and it's earth. So what happens? If there are, let's say, 1, 2, 3, 4, 5. There are 5 charges. What happens? These negative charges will move down and the positive charges would spread across. Okay, if there is 5 negative charges, then 5 negative charges, positive charges will come to this side. 5 negative charges will go to that side. And then the negative charges moves down and this positive charge takes its place. So this becomes positive. So what is the conclusion? When you induct or when you induce a current, what happens is, if this has 5Q minus 5Q as charge, then the neutral body will have a charge of plus 5Q. Okay? So this is about induction. The next we learn about, just to give you a rough idea of what is conductors and insulators. So conductors, what are they? They allow electricity. So electricity is allowed. Whereas for insulators, what happens? It is not allowed. Electricity is not allowed to pass through it. So why is it conductors allowing electricity to pass? That is because there is free electrons There are free electrons in conductors, and that is why conductors allow electricity to pass through them. So, the next one is known as the Coulombs Law. So, we will discuss about the Coulombs Law. So, what is the Coulombs Law? The force between two charges, 2 point charges, is what it gives. So, the force between two charges is directly proportional to what? The product of the charges. If you take the charges to be Q1 and Q2, so it's directly proportional to Q1 into Q2, and F is inversely proportional to square of the distance between them. Okay. So what do we infer from this? Implies F is proportional to, so not equal to, F is proportional to Q1 Q2 by R square. Okay. Now to remove the proportionality, what do you use? The proportionality constant. So we will see the proportionality constant. F is equal to K Q1 Q2 divided by R square. So K is the electrostatic constant. So K in the CBSE unit is taken as, K in CBSE unit is 1. But in SI unit, we discuss about SI unit. So in SI unit, K is equal to 1 by 4 pi epsilon 0 into epsilon R. Okay. Epsilon 0 is permittivity in free space and epsilon R is permittivity in a medium or the relative permittivity. Okay. So we learned about the Coulombs law. Now we have to learn the vector form of Coulombs law. Okay. So to learn about the vector form. So this is vector form that we are going to learn, vector. So the first point that we have to learn under vector form is, first we'll draw a graph. Not a graph, it's the point marking it. Okay. So we'll mark 2 points A and B. Over here we have what? Q1 charge and Q2 charge. So this is away from the origin. This distance away from the origin. So we will take this as R1 and R2. Okay. And there's a distance between the two charges. Now we have to find the distance between the two charges. So that is this distance. This distance is R12. Okay. We found out that also. Now what should we find out? The force. So what is a force? Force acting on Q1 due to Q2 is equal to F21. We represent force acting on Q1 due to Q2. So Q2 is acting on Q1. So F21 is equal to, what does the equation say? K is 1 by 4 pi epsilon 0. We will write it 1 by 4 pi epsilon 0. And what is our charges? Q1 and Q2. So Q1 into Q2 divided by, what is our, distance between the two electrons, that is R12. So R12. There should be something to write the cross because it's vector form. R12 cap. Okay. This is the F21 force. Now that is over here. That will act towards this side. F21. Now to this side, the force acting on Q2 due to Q1 is F12. So F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by, what is the distance? Distance doesn't change. R12. Okay. Into R12 cap. We learned it is R square. I forgot to mention the R square here. So it's R12 square. Okay. Now we will make this to the vector form. Okay, this is R12 cap. Now we will write it in the vector form. So F21 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 this whole square into R12. It's because you change this to R12 like this. Okay. So the next one is, so this, what will the denominator become? the denominator would become R1 to the whole cube because we multiplied it by one more R12. So the next one, F21. Sorry, now we discussed about F21. So F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by, the same process happens here. You multiply it again by R12. So it becomes R12 the whole cube into R12. That's the form. So this is the Coulombs law in vector form. So now we have to discuss about the two terms in the equation. So first one is epsilon 0, the second one is k. K is equal to 1 by 4 pi epsilon 0. So we find out the value of epsilon 0 first. We know that epsilon 0 is equal to 8.82 into 10 raised to minus 12 Coulomb square per Newton meter square. So this is the value of E0 cell. Sorry, not E0 cell, sorry. Epsilon 0. And then K. K is equal to 1 by 4 pi epsilon 0. We know the value is equal to 9 into 10 raised to 9. 10 raised to 9 Newton meter square per Coulomb square. Okay. So this is the values. Now we will see, we'll equate the equation of force to something. Okay. So let's see. We know F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Okay. So let us assume Q1 and Q2 is equal to what? 1 coulomb, and R square is equal to 1, not R square, R is equal to 1 meter. Okay. So what would this equation transform to? F is equal to 1 by 4 pi epsilon 0, 1 by 1, that is equal to 1 by 4 pi epsilon 0. So what did we get over here? F is equal to 1 by 4 pi epsilon 0. We learned what is 1 by 4 pi epsilon 0 just before. That is 9 into 10 raised to 9. So F is equal to 9 into 10 raised to 9 newtons. The unitive force is Newton. So this is the answer. So now we'll write 1 coulomb charge. 1 coulomb charges with 1 meter distance apart will experience a force of 9 into 10 raised to 9 newtons. So we'll define 1 coulomb now. So 1 coulomb is the unit of charge which experiences a repulsive force of 9 into 10 raised to 9 newtons when kept with a charge of 1 coulomb in free space or in vacuum at a distance of 1 meter square. So that is how you define 1 coulomb. Now we will have to define we discussed about that small quantity. Now we will discuss in detail. Okay. So epsilon R, I told you, that is relative permittivity. So what is F vacuum? What is F vacuum? That is 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Yeah. If the same force at the same distance is kept in a medium, what would happen? F medium is equal to 1 by 4 pi epsilon, because epsilon is the value of permittivity in medium. So that is epsilon into Q1 Q2 divided by R square. Now we have to write about what? Epsilon R. Epsilon R is equal to F vacuum divided by F medium. So we'll write that over here. Epsilon R is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. divided by 1 by 4 pi epsilon q1 q2 divided by r square. Cancel, 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 cancel. Now what is there? There is epsilon 0 by 1 by epsilon r. 1 by epsilon 0 by 1 by epsilon r. What will we do? We'll put it the other way around. 1 by epsilon 0 into epsilon divided by 1. Tongue, it gets cancelled. And then it becomes epsilon is equal to. So, this is how you define this. Now, if it's given, the relative permittivity of water is equal to 80. What is it given? Relative permittivity of water. So, ER of water is equal to 80. How will you find out the E? E is very simple. E is equal to, what is it? ER is equal to epsilon divided by epsilon 0. So, E is equal to ER into epsilon 0. ER, we know it's 80. Epsilon 0's value is 8.82 into 10 raised to minus 12. Then it's easier to calculate. That's all. Now we'll discuss about principle of superposition of charges. So, superposition of charges. So, we'll write. We know the equation of force. F is equal to K Q1 Q2 divided by R square. So, and now we have to discuss about what? We have a point charge. Let's say, let it be here. This is Q0. And there are so many other charges around it. So what should we find out? We should find out the force experienced by Q0 by when these forces act on it. Yeah? So we have to find this. So let us see. So we know, according to principle of superposition, the total charge, it is the, vector sum of all forces acting on the Q0. Okay. So we will find out what all are the other charges. So F total is equal to F01 plus F02 plus F03 plus F0n. Okay. So we will find out how to derive F01. F01 is equal to K into Q0 Q1 divided by R01 square. We will write it R10, okay? R10 square into R10 cap. This is the value of F01. We will write for F02 also. F02 is equal to K Q0 Q1 Q0 Q2 divided by R20 into R20 cap. Similarly it goes. So we'll find out F total. Yeah? F total is equal to K is common because K, everything is K. K into Q0 Q1 divided by R10 square plus Q0 Q2 divided by R20 plus it goes. So what will we do now? Now we have to write F total is equal to K. K is common. So now we put this under sigma. So sigma Rx is equal to I and over here it's N. Q0 Qi divided by Ri0 square into Ri0 cap. Okay. This is the equation for principle of superposition of charges. So next we have to learn about the arrangements or charge distributions. So we learn about that. So charge distributions are of three types. one-dimensional charge distribution, two-dimensional charge distribution, three-dimensional charge distribution. So what is this one-dimensional charge distribution called as? That is linear charge distribution. So that is linear charge distribution. The second one is surface charge distribution. The third one is volume charge distribution. So first we learn about linear charge distribution. So linear charge distribution. So what is linear charge distribution? When the charge is distributed in a line, in a straight line, or to a circumference of a circle. It is known as what? Linear charge distribution. Linear charge distribution. This is called linear charge distribution. So if you take this length to be L, so linear charge distribution is represented by lambda. So lambda is equal to Q divided by L. Okay? What is this linear charge distribution? Now we learn about surface charge distribution. Surface charge distribution is represented by sigma. Okay? So we'll write it. What is surface charge distribution? If the charge is distributed over a plane of a surface, it's known as surface charge distribution. So what? Spread over surface. This is surface charge distribution. Okay? So we'll write the equation. Sigma is equal to Q divided by what? Over a surface, what is that? Area. So let's assume the area of a surface to be A. So this is Q by A. So this is surface charge distribution. Okay. Now the third and the last one is volume charge distribution. What? Volume charge distribution. That is represented by the letter rho. Okay. So what is volume charge distribution? When the charge is distributed over a volume of an object. So charge is spread or distributed over the volume of an object. Okay. So what is the equation for that? That is rho is equal to Q divided by, we'll take the volume of the object, let's say maybe cube. The volume of the cube is equal to capital B. So this is equal to this. So implies what? This is the equation for volume charge distribution. Okay. So friends, this is all for today's video. I hope you might have liked it. I will be putting the notes in the description below. Hope you liked it. If you liked it, please do hit the like button. Subscribe to my channel if you're new. Share my video to your friends. So if you have any queries, please ask me in the comment box below. So see you in my next video. Till then, bye bye.